Software company is interested in improving customer satisfaction rate from the 66% currently claimed, and they get this sample. I'm trying to copy it here. Just write it over here. So they have a sample. They got 189 people, and 136 were satisfied. So P hat is going to be 136 divided by 189, because the sample proportion is just the proportion of successes. You had 136 divided by 189 that were, I forgot what it was, satisfied or something. So 0.71958 when I round. So that's your sample proportion. So if they want the test statistic for any sort of hypothesis test you do for proportion, it's Z for test statistic, and that's equal to the sample proportion subtracted by like the hypothesized value, the previously known value. I shouldn't say hypothesized value because that could be confusing. So the previously thought to be population proportion was 0.66, or in other words, the test value from our assignment. And that's divided by 0.66 times 1 minus 0.66. This is the P in the formula for the test statistic. And then divide by the sample size of 189. Okay, so just let me know if you want to see that formula without the actual numbers in it. But what I do to save myself some work is I do the denominator first. I know 1 minus 0.66 here. Well, if I don't know, I could just type it in. So that's what the parentheses is. That's multiplied by 0.66. Then divide 189. And then take a square root. So that's the denominator. And so the numerator, 0.71958 subtracted by 0.66, that's our numerator. And we're going to divide that by the denominator. So it's 0.17291 if we round. I don't know how many decimal places they want. Okay, same type of thing here. They want the test statistic just like we did over here on the whiteboard off to the side. So we're going to repeat that process, but then they want a p-value. I'll show you how you can grab that off any sort of z-score calculator online. So they think the population proportion is 0.64 in the past, and they have a new sample, so they get a p-hat of 177 were satisfied out of 261 customers. So that's 0.67816. Just carry out some decimals there. And so what's their claim? They want to improve customer satisfaction. They want to know whether it's, that customer satisfaction rate is higher. So their alternative, the thing they're trying to test, is that the proportion is higher than the previous 0.64. That's the claim that they're trying to test. So that's a right-tailed test. We'll want to keep that in mind when we eventually look up our z-score in an online calculator. So plugging that into our z-score formula, just like we did in the last problem, 0.67816 subtracted by 0.64 divided by, now it's a square root of p, which is 0.64, times 1 minus p, divide by the sample size. And that n is inside the square root here. So watch out for that. So again, doing it all at once in the calculator, I'm going to do 1 minus 0.64 in the denominator first, then times 0.64, then divide, oh, I just wrote n, I didn't write the number, it's 261 for n. And then I'm going to apply a square root, and that's scientific notation, by the way. But then I'm going to apply the square root. Let's copy this, and now we can do the numerator, 0.67816 subtracted by 0.64. Divide by the denominator. So we got a z-score of 1.28436. So that's what we want to use. If you just Google search z-score to percentile calculator, take the first one that comes up, then you can type in the z-score you've got to convert it to help you find a p-value. Remember, the direction of the hypothesis matters. Right? If it was left-tailed, right-tailed, or two-tailed. We had a right-tailed test because we were testing to see whether the proportion was greater than 0.64. Whoa! I clicked some ad. So our right tail is 9.95%. So as a decimal, it's 0.0995. So here was our test statistic. We got 1.28436. Our p-value was 0. Oh, whoa. No, it's going to make me redo the whole thing. Oh, maybe not. 0.0995 for our p-value. Is there sufficient evidence to reject at the alpha 0? Our p-value is bigger than the alpha. So no, there's not sufficient evidence to reject. This one is the same one, so I'll leave this for students to do because there's not a whole lot of randomizations. I might be giving away the answer for one of these. When you do this one, they say whether it's different. This is a two-tailed hypothesis. Okay, so that's the big hint I'll give you. This is a two-tailed hypothesis, so make sure to look up a two-tailed p-value in that calculator I just showed you. Don't use the right tail, use the two-tail.